ShellcodePack is a payload generation software centered around the launch and weaponization of shellcodes. It is an offensive security tool used for initial access as well as assume breach and post-exploitation scenarios. The possible generation formats include raw shellcodes, all kinds of Windows Portable executables such as exe, dlls, cpls, and more. ShellcodePack can be used as a GUI tool or as a command line program, with both offering the exact same features. When opening up ShellcodePack, the interface is separated into multiple points of interest. The list of architectures, which determines which Windows architecture you are targeting, including an option to target both in some situations. The inputs, which will determine the content of the payload. You can provide raw shellcodes, portable executable files, C files, .NET files, and more. You can also use pre-made shellcode templates such as TCP or HTTP stages, command line execution, and executing a syscall for a given anti-Windows function. The output settings will determine everything related to the resulting files, such as path, name, format. You may choose within a varied list of output formats, such as most portable executable formats, C source code, assembly files, Python source code launching the shellcode, and more. You can also choose to trojan an existing portable executable with your shellcode. Finally, you can choose what type of archive or file will contain the payload after generation. This includes some less conventional containers, such as HTML files or MSI installers. After setting these options, clicking Next will move us to a more detailed second screen, offering us to fine-tune our payload further. In the second screen, the options are split into multiple categories, which may or may not be available depending on the selected format. Shellcode options affect the provided shellcode, meaning they can be used even when the output file is a raw shellcode. They allow you to encrypt and obfuscate it. They also allow you to prepend or append assembly stubs to check for a specific domain name, disable event tracing, or ensure NTDLL and kernel32 are not proxied by patching the DLL order. C-based launcher options affect the generated C code when building a portable executable payload. The C code is in charge of all the steps leading to the execution of the shellcode. You may choose the exact way the shellcode is executed, how the shellcode is initially stored in the executable, and how it is copied to the executable area if necessary. This allows you to determine whether for the shellcode executable memory is located, its page protection is changed, or an executable section is built into the executable. It also allows you to choose whether to use native Windows callback for execution, such as setTimer, createFiber, enum UI languages, or to directly execute a pointer to the shellcode. For EDR and antivirus bypassing, you have access to a varied list of emulation bypass methods, which are tried and true ways of detecting dynamic analysis and preventing execution in this scenario. Still on bypassing, multiple function unhooking and ETW patching methods are available to you. Finally, the shellcode can also be made to be stored as unique UIDs or English words when bypassing heuristic analysis is required. Social engineering options are more targeted towards tracking humans and making the payload look less suspicious. It offers options such as icon customization, extension spoofing, file certificate spoofing. It also allows you to artificially inflate the file size by creating a new, empty section of the desired size. Finally, at all times, the command line equivalent of the selected options is shown here and can easily be copied into the clipboard. With most of the interface presented, I will demonstrate basic use cases to show everything in action. For my first example, I will generate an exe with a spoofed PDF icon and extension that will execute a .NET Rubius payload. First, I will set the architecture to x64 and provide the Rubius exe as an input. Then I will open the list of output formats to select exe before moving on to the second screen. In the second screen, I will scroll down to the C-based launcher options and enable console logs, as ShellcodePack hides open consoles by default, but Rubius requires one in order to work. I will then scroll down to the social engineering options, write PDF in the spoofed extension field, and provide the path to my PDF icon. I can now generate my file, and I now have my exe that looks exactly like a PDF and that launches my Rubius payload. For my second example, I will generate a raw x64 shellcode that will contain a HTTPS stager and execute whatever payload the HTTP server serves back. First, I will select x64 in the architecture list. I will switch to template inputs, select HTTPS stager in the template list, and write the full URL where the stager will get the payload. Then I will keep the output format as raw shellcode, move on to the second screen, and generate my file. I now have my shellcode, which I will use in the next example. For the third example, I will trojan an existing exe, here it will be putty, with the previously generated HTTPS stager shellcode. I will start off by matching the x64 architecture of my shellcode. I will provide the path to the stager shellcode I generated before, and in the output list, I will switch to Trojan mode and provide a path to the x64 putty exe. I will also make the payload start in a thread in parallel so as not to delay or disturb the execution of the original code. I can now go and generate my payload. Now, at the current time, I don't have an HTTP server running, so in order to test my payload, I will open the ShellcodePack test servers window to quickly host one. After providing the correct port and a working directory, I can click Run, and my server will stay open, printing every request it receives in the newly opened console. I can now run my payload and observe a received request on the previously configured path in the server console. By placing a payload under this path in my server directory, I can freely change the payload that the stager obtains, this without having to regenerate a payload. For example, I can provide a simple shellcode that starts the calculator, that prints a dialog, or even one that connects to a C2, helping me test things more easily. These examples were very simple in order to showcase how ShellcodePack works. If you want to see better use cases, such as specific antivirus or EDR bypasses, C2 payloads such as Sliver or Mythic, and more varied options, you can check our Vimeo or YouTube channel, where plenty of videos are accessible and where new ones are frequently uploaded. In conclusion, ShellcodePack offers quite a hefty amount of features for pentesters and red teams that are very varied and that will take a lot of time to implement yourself on your end. By using ShellcodePack, you will benefit from our research and development, and therefore gain some time and expertise. Additionally, new features regularly get added, and existing features regularly get updated or improved so as to keep up with new techniques and circumvent the ever-growing new securities EDR and antiviruses possess. Thank you for watching this short demo. You can visit bydeskit.com if you are considering obtaining ShellcodePack or MacroPack, and you can follow our Twitter and LinkedIn for news and updates about what we do.